What's scary to me about the new coronavirus is anytime you have something new, you just have many unknowns. And we don't know how fast this is going to spread, and we don't know how infectious it's going to be if it were to spread worldwide. What makes coronavirus a particular challenge is that, like all viruses, it has a capacity to change. And so, as what we know about related viruses such as SARS doesn't always tell us exactly how to treat or prevent illnesses in people who might contract this particular coronavirus. And so it's important for us to generate scientific information as fast as possible to determine if what we know from having studied SARS will apply to this new coronavirus. The machinery that makes up the viral particles has many different functions. And so a great example would be if you were a factory, you might have many different kinds of machines that would be used to produce, for example, a car. And if you can block those machines from functioning, you could block a car from being assembled. A virus works the same way, and it has to actually make many different components of that virus before that virus is fully intact. And many of those different machines can be blocked by introducing chemicals which can be developed as drugs. This protease structure, but this is the protein from the SARS virus. We specialize in understanding protein structure. So proteins are the little components that actually make up the viral particle, but they're also the components that make up the machines that will build that particle. And we're particularly interested in the structure of those machines so we can understand how to keep those machines from functioning by introducing chemicals or potentially drugs that would block the function of that machine. The timeline in order to produce the kind of information that we're looking at can be on a weeks to a month scale. So what we can determine in a very short period of time is the structure of the new viral machineries or the new viral particle pieces, and we can ask if drugs that were developed in the past to treat other viruses will be useful to treat this new coronavirus. We have taken information from the viral genome, which is the code of that virus that tells how to build the viral particle. And we have taken that code and we're using it to generate three-dimensional information about what these machines will look like. We're trying to determine these three-dimensional structures so that we can compare them to SARS, the goal of which is to determine if drugs already developed for SARS could be useful for treatment of this new coronavirus.